This is the example on slide 87 of our chapter 13 PowerPoint, and the question asks, we can make a saturated solution of barium carbonate by adding solid barium carbonate to water and stirring until equilibrium is reached. What is the numerical value of KSP for barium carbonate if the reaction mixture contains 5.1 times 10 to the negative 5 molar barium 2 plus and 5.1 times 10 to the negative 5 molar carbonate ions. So this is just another variation of an equilibrium problem. Here our K is KSP, which stands for solubility product. So basically this is an equilibrium between something that is insoluble in solution with its ion components. So for these types of problems, typically you're not given a reaction. You have to write that yourself, but it's pretty simple to do. So our problem states we're dealing with barium carbonate. And to write a reaction for this, basically it's showing barium carbonate breaking up into its individual ions. That's all you need to include. So to start writing it, it's going to be barium carbonate, which it tells us is a solid. And that's going to be in equilibrium, that's what these double-headed arrows mean, with its ion components. So here we just need to see how barium carbonate breaks apart in solution. So this compound is composed of barium 2 plus ions, and in solution those are aqueous, and carbonate ions. Now carbonate is one of your polyatomic ions, so you might need to go back and consult your polyatomic ion table if you don't remember that. And so it's CO3 2 minus, and it's also aqueous. So when barium carbonate is dissolved in water, it breaks up into Ba2 plus and CO3 2 minus. So now that we have that equation written, we can write an equilibrium expression for it. And then ultimately what we're going to do is plug in these two numbers into concentrations of our ions to figure out exactly what the number value of KSP, or our equilibrium solubility product, is. So we write this just like a normal equilibrium expression. KSP is going to be equal to products. So look real quick at the phases. Both are aqueous, which is one of the things we can include in an equilibrium expression. So on top it's going to be Ba2 plus times CO3 2 minus. And neither of those are raised to a power because they both just have a 1 in front of them. And then we look and see, are we going to include anything on the bottom? Now notice here that barium carbonate on the reactant side is a solid. So that means we are not going to include him in our equilibrium expression. And so we're not dividing this by any reactants, and that's okay. We can have just an equilibrium expression of just our products. So KSP, our equilibrium of our solubility product, is going to be equal to concentration of barium ions times concentration of carbonate ions. And now that we have that written, we can plug our values in that were given to us. This 5.1 times 10 to the negative 5 for both components. So that ends up making KSP equal to 5.1 times 10 to the negative 5 times 5.1 times 10 to the negative 5. And if you plug that in, multiply those two values, you should get 2.6 times 10 to the negative 9. And that is your value of KSP. And there you have it.